So maybe it's time to do something. Hopefully it's a little easier. Although day 6, that's when things start to, the cliff starts to get steeper. I'll give it a shot. Day 6, Universal Orbit Map. You've landed at the Universal Orbit Map facility on Mercury. Because navigation in space often involves transferring between orbits, the orbit maps here are useful for finding efficient routes between, for example, you and Santa. You download a map of the local orbits, your puzzle input. Okay, let's get that. Ugh. Okay. Over 1,000 entries there. Except for the Universal Center of Mass, COM, every object in space is in orbit around exactly one other object. An orbit looks roughly like this. In this diagram, object BBB is in orbit around AAA. As what BBB takes around AA, draws the lines is only partly shown. In the map data, this orbital relationship is written AAA close paren BBB. Before you use your map data to plot the course, you need to make sure it wasn't corrupted during download. To verify maps, the Universal Orbit Map uses orbit count checksums, the total number of direct orbits, like the one shown above, and indirect orbits. Whenever A orbits B and B orbits C, then C indirectly orbits A. This chain can be any number of objects long. If A orbits B, B orbits C, and C orbits D, then A indirectly orbits D. All right, so we just build a tree. I'm thinking hash map because that's my default, that's my go-to. And then we can use this as test input. All right. AOC 2019. Let's spin up a new puzzle input here, or new puzzle program. Day 06. $1 changes to 19, and $2 is 06. All right, AOC 2019, Bacon, Clippy, run. Okay. What's the total number of direct and indirect orbits in your map data? Okay, there's 42 here. D directly orbits C and indirectly orbits B and COM. Okay, so we just work our way up the chain. I got it. Yeah, I think a hash map should do the trick, right? Orbit. We're going to hash map a string to a string. All right, let's parse this. I'm actually going to separate it out into a separate thing so I can run it as a init, and maybe we'll just give it lines, which is going to be stir. I don't know if I can do that. It might have to be like this. And then mutable reference to self, reference to immutable self. Oops, I forgot this part. Ceph. Okay, now we're good. Now what we'll do is we'll say for line in lines, let left right equals line split once on the orbit, unwrap. And then we'll insert into, say, self orbit, insert left, right. Like that. And now I should be able to write a test for it. Honestly, can I? No. I gotta fix that. This saved me a bunch of typing here. Example 1. So we're going to say let AOC equals AOC 2019-06 default. That should work. It says unknown. Why? Oh, I know why. I got a typo here. Oh yeah, these. So we need to clone these into. Yep, and now we'll say AOC dot init, and we're going to just give it these strings here. Like this, like that, and then like that. Okay, maybe that'll work. And now we want to assert EQ 42. Oops, I don't know why I typed 64 when I said 42. Right, it said 42 here. So we're going to say count orbits, AOC count orbits. And this doesn't exist, so now we'll make it inline macro. FN count orbits self usize. We're going to return 0. And then we're going to run tests. Okay, so this doesn't work. Oh, we need to pass in a reference. And this still doesn't work. Oh, because it's expecting strings. I keep forgetting how to do this. Like this. And we can't do a split once. There we go. Okay. So we should also be able to do this up here with parse. Let lines equals AOC lib read lines 2019-06.text and then say self init lines if we borrow. Yeah, so that also builds. All right. Now I think we just need to loop over every value or every key and then count up how many ancestors it has. Right? This is 0, this is 1, this is 1, 2. So it's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on. Yeah. So I think it's just for L. So it's just, we have to loop over the values, right? Not the keys. So we don't care about that. So if we can say for, are these planets? What are these called? Objects. They're just called object. In self orbit values. And now we'll just work our way backwards from that orbit and say if. Oh, how do we do that? Do we have to map it the other way around? Yeah, let's map it the other way around. And then his keys. While, can I do this? That's the question. While let some parent equal self orbit get object total plus equals 1 object equals parent. Will that work? It passes the test for the sample data. Right? If we look here, we can see it says okay. So it's adding up the right number. Dare I try it? Oh, I'm not calling it. Let's call it. And all it is self count orbits. It panicked. Oh, because it's probably 6, not 06. No. What's the name of the file? 2019-06. Oh, input. Adodo says, I think it'll work. We still need to figure out what I did wrong here. Let me just copy the file name. Now, am I in the wrong directory? What's going on here? Oh, it isn't here. Oh, I put it in the wrong. I was still in 2018. Okay. Input 2019. There we go. Okay, one more try. So we got this number, 147,223. Hey, that's the right answer. Okay, that wasn't too bad. I don't know what it's going to do for the next one. Git status, git add source, git commit -m 2019 day 6 part 1. Okay, let's take a look at part 2. Now you just need to figure out how many orbital transfers you need to take to get to San. Oh, you started the object you are orbiting. Your destination is the object San is orbiting. An orbital transfer lets you move from any object to an object orbiting or orbited by that object. For example, suppose you have the following map. Visually, the above map of orbits looks like this. So we need to find a path from U to San. What's the minimum number of orbital transfers required to move from the object you are orbiting to the object San is orbiting? You are orbiting around K. San is orbiting around I. So you need to go from K to J, J to E, E to D, D to I. 1, 2, 3, 4. That's why it's saying here, not between you and San. So how do we do this? Right now I can only go backwards. I can't go forwards. So do I need to modify my parent-child relationship here so that we can go forwards as well as backwards? Scoop says go from U to come and then from San to come and find a crossover point. Right? That'll tell us the common parent, right? Oh, yeah. And then we just work backwards. That makes sense. And we work backwards again from U and San to count how many that is. Right? We're here, so we go 1, 2, 3, and here we go 1. So 3 plus 1 is 4. At least last time I checked. We can try that. let mut that way we can keep count while we're doing it. And that's from U to com. Let's say U to com. And this is from San. And that way we can walk backwards on each one. Connected is true. Well, I mean, if you can get there, if you can get to com, you definitely have a path between them. So they're definitely connected. So hopefully they're connected. Let's see if we can figure out U to com. Let mut object equals self orbit get U unwrap, while let some next equals self orbit get object let steps equal 0. Actually, you're going to start off at 1, right? Then we're going to say steps plus equals 1. And we're going to say, when we say U to come, insert next steps. Let's say we might be off by a little bit. And then we'll say object equals next. So now I should be able to print this out and see what it looks like, right? I forgot the output here. Oh, now we can do that. Run. Ooh. Okay. So each one of these should have a step, right? And it's not in any particular order, but at some point there should be a com. I'm looking for it, but my eyes can't find it right now. That's the top of the tree, and U is not in here because I skipped that one. So we should be able to do the same thing for Santacom. At some point, they're going to be equal, right? So we should be able to actually see it in the U to com. So we don't need to actually insert this, right? All we need to do is work our way backwards, counting the steps. If U to com contains key next, then return AOC lib output steps plus let some U steps equals get next. I don't know if that'll work because it's a reference to a string. We'll see if that works. Steps plus U steps. Otherwise, object next and then unsolved. 342. Does that sound reasonable? It's too high. All right, well, let's use the test input then. This says 4. I'm probably off by a little bit. All right, so we're going to do for this. Oh, we have to extract this out now. And what we'll do is we'll just make it an option thing here. FN, what are we going to call this? Transfers. Orbital transfers self and it's going to be an option view size. And that way we can say some here, or none, if we don't find an answer. And down here, I'm going to say assert equal 4 for orbital transfers. Oh, no. Different input. It's probably the same with these 2 additional steps. Com B, B, C, C, D, D, E, E, F, B, G, G, H, D, I, E, J, K, J, K, K, L. Okay, yeah. So we can just do 2 separate steps here, tests. If an example 2. And we'll just add these 2 extra ones here as K, U, and I, SAN. Let's run the tests. And now there's no implementation for that, so let's fix that. We came up with 6, so I'm probably adding in before I should be. Okay. And now if we run the real thing, self orbital transfer, unwrap, run, 340. Is that lower than? It is, by 2. Hey, that's the right answer. Okay. So again, I want to do the back and forth thing until we can get all the previous events done.